Video will be devoted to formulas, and I'm going to start with some problems that are actually using formulas. So each of these problems present a real formula. They tell you what the formula calculates, then they give you some suggested values to substitute in for evaluation. This should be very, very simple, but I wanted to start with this before we get into the literal equations, what we're actually going to be quizzed on this year, tested on this year. So the first formula here calculates distance. Distance is a function of rate times time. So to calculate the distance you would travel at 52 meters per second in 8 seconds, you would just be simply substituting these numbers into the formula in place of the variables. And I'll let you figure that out on your own. The perimeter formula, this is a formula that we will use a lot this year. So the perimeter, I would calculate 2 lengths plus 2 widths. So you're just simply taking the values that they give you and you're putting them into the formula in, just substituting the variable in the formula with the number that's given. And I know that you all are capable of following along with this, but understanding what you're doing is the more important piece of an exercise like this. I would like to look at number 6 and 7 for just a minute before I move on to the next topic, or actually 6, 7, and 8. Note that they all contain a variable that's squared. So just make sure, we'll look at number 8. Just make sure that when you make a substitution with that number, so this is going to be a width, you're going to square that 7. And I just wanted to make sure that you catch that. And then as you continue on, you'll have 4 times 10, and then the 7 comes back again. So order of operations tells you which to do first, and then how to combine up and get your final answer. I'm confident that you all can get through that, but I did want to start the exercise with a little review of formulas. Let's move on to the literal equations. And a literal equation is taking a given formula and solving it for a suggested variable. The reason this is important is because sometimes when you're dealing with formulas, you're not always given the information exactly in the order that you want. And sometimes you need to do some thinking and working in the reverse in order to use the information that you've been given. So number 3, the distance, rate, time. If I wanted to calculate the time, I would simply multiply both sides of the equation by 1 over t, and then that would, 1 over r. I'm trying to isolate time, so I would multiply both sides of the equation by 1 over r, and then that would be, the inverse property of multiplication. This product would be 1, so then I would isolate the t on the right-hand side, and then the left-hand side would be distance divided by r. So that would be the simplified version of that formula by isolating the t. Let's look at number 6 on the video. And number 6 is the area of a circle. I'm trying to isolate r to the first, but what I have is actually r squared. So the first thing I should do in something like this, at least isolate r squared. And I would do that by multiplying by 1 over pi. So that gives me area over pi, and that's going to be set equal to r squared. And then in order to inverse r squared, I would need to take the square root of both sides. And in doing that, I would now have, I'm out of room over here, so the left-hand side is still going to remain as area over pi, but instead of equaling r squared, it's now just going to equal r. And we had a little discussion about that in class. Let's move on to the other side. Now let's move on to the other side. And looking at some of the problems over here, something like the area of a triangle, number 9, and I will write it larger just to show you how simple this really is. The first thing I'm going to do is take care of 1/2. So I'm going to multiply both sides of the equation by 2 over 1. So that leaves me with a 1, and now I have 2a and base times height. I'm now going to move the base to the other side, so I'm going to multiply by 1 over b, leaving me with a 1, and now I have 2a, b in my denominator, set equal to h. Let's look at a problem like number 12. I'm trying to isolate the b, which is in the numerator, so the first step is to multiply both sides of the equation by d over 1. And when I do that, I'm going to have a times d on the left-hand side, and it's going to be set equal to the numerator only. And now in one step, I just need to subtract c from both sides, ad minus c, and I've isolated the variable b. Okay, they start to get a little more complicated as you go. Let's look at a problem like the perimeter problem in number 13. So I'm asked to isolate the width of the rectangle in this particular problem. I think the easiest thing to do right now would just be to simply subtract 2 lengths from both sides. And now to isolate the w, I need to multiply by 1/2. But the trick is, since I've got this expression, p minus 2l on the other side, I need to put it in parentheses so that both terms on the other side pick up the factor of 1/2. So I've now isolated the w on the right-hand side, and then on the left-hand side, I can present my final answer like this, or I can write it as one expression. P minus 2l is my numerator, 2 is my denominator, and I set it equal to w. Both presentations are exactly the same, and they're both correct. So you can choose the presentation that you like best. Let's look at number 14. So in number 14, your job is to isolate the y. So the first thing I would do would be to subtract 8x. And using the same logic that I used on the perimeter formula, I'm now going to multiply both sides by 1 over b. And I need to put that in parentheses so that both terms pick up the factor of 1 over b. And now inverse operations, I'm left with just y alone. And I can set it equal to 1 over b using parentheses. Or I would have the option to write that as one single fraction. The denominator would be b, and then my numerator would be c minus ax. So both presentations are the same. They're both right, and you can just choose the presentation that you like best. Okay, let's look at something like number 16. It starts to get a little bit more complicated. I'm trying to isolate the t, but the problem is the p occurs in 2 places, and there are 2 ways to do this. So I'm going to go ahead and introduce the thought of reverse distributing. Since both terms share a p, if I reverse distribute, which means I'm going to pull it out instead of multiplying it back through, what would I need to multiply the blue p by in order to get the original p that I started with? And that would be a 1. So what would remain behind in parentheses would be the factor that I need to multiply the blue p by in order to get what I started with. So if I remove a p from the PRT, what's going to remain is RT. When I reverse distribute, I always will check my work by distributing what I've pulled out back into what's left behind in parentheses to make sure that I get the same thing that I started with. I'm not changing the value, I'm just rearranging it into smaller pieces. And now in doing this, this enables me to multiply both sides by 1 over p. So I now have a over p, and that takes care of what's happening over here. And now what I would do is subtract 1 from both sides. So I'm going to have a over p, I'm going to take away the 1, that's going to leave me with r times t. And since I'm isolating t, I'm now going to multiply both sides by 1 over r. And since I've got this summation on the other side, I need to put it in parentheses so that everyone would pick up the factor of 1 over r. And this allows me with multiplicative inverse to isolate the t successfully. And then on the other side, I'm going to have 1 over r, and then in parentheses, a over p minus 1. And that looks a little clumsy, but I think I'm going to leave it like this because I think it's easiest for you to see each individual piece and how all of the terms have been manipulated to the other side of the equation. There are other ways to present what I've boxed in red, but I think for now I'm just going to leave it alone like this. We will do the Celsius Fahrenheit. Number 17 is actually Celsius to Fahrenheit. We will do that together in class, but you're welcome to try it if you want to. The first thing I would do would be to multiply by 9 over 5. I'll start that for you. And then I would have 9c over 5. And then by multiplicative inverse, I'm left with f minus 32. I'm going to let you all take it from there on your own and clean that up. And then bring your questions to class, and we'll just take care of everything in class.